Okay, so this next one, I promise you that the first reaction you're going to have is like kind of eye roll, like, no, really? This is a thing? Yeah, this is really a thing. And it's something that shows up, again, it shows up pretty big in C. And it kind of had its origins in assembly language. You know, back in the days when I first did assembly language professionally, the late 80s, there was the classic Intel assembler that we used was, we called it MASM. It was the Microsoft assembler that they made. But it was actually called the macro assembler. It was called the, I can't remember, like the Microsoft macro assembler, you know. And macros was part of the thing. It was some of the power that you could build, basically this macro replacement, right? So macros, you know, the idea basically is like a textual replacement. You have to think of this as a text replacement. It's a little weird. So let's hit the text here. So when you're passing parameters by macro expansion or just by macros, the body of the macro is evaluated in the caller's context. I'm going to break that down for you and help you understand what that means. Okay, the body, the text of the macro is literally like swapped. There's no caller. That's the point. There's no real caller. What looks like a caller says, take this, replace it with this, expand it, blow it up, and then treat that like it was always there. It's kind of funky. Okay, then so the actual parameter is evaluated on every use of the corresponding formal parameter, which I'll show you kind of where that comes into play, in the context of the formal parameter. And again, these words are horrible. This is not helpful. C macros, big thing. But the bottom way to look at that is as textual swapping before you compile. Here's what it looks like. This is our classic, right? We edit, we make a source file, we compile into assembly language, right? Well, there's another one, which is a preprocessor that creates expanded source. All that really means is every macro in your source code gets blown into the expanded version of that macro. So text yields text. That's what you got to understand. So watch this for a second, and this is going to make sense. I promise you. So here's what happens. I've got this source that I define a macro. This is my definition, okay? I do a definition of a macro. The pound define in C says I've got min, capital min, paren, paren, xy, close paren, and then just white space. And what that says is later on, when you use min, pound define, I already told the compiler what to do with this. Whenever I see big min, all uppercase min, with two things, for example, A equals min BC, right? Which you'd just be thinking that's just going to make the smaller of B and C, right? Well, what we're going to do is whenever I see that, I'll take B and put whatever they put here, literally textually, whatever they put here, I will replace for every instance of X. Whatever they put here, text, I will substitute for every instance of Y. So therefore, when I go, this is my macro, X, Y, and this is a ternary operator, right? If X is less than Y, then return X, otherwise return Y. That's the ternary operator in C. And what I get is over here. Literally, the B goes where the B replaces the X. C replaces Y. B replaces X. Why these parens? Anybody? Bueller? The reason why we have these parens in our macro is because there's no guarantee that they are going to provide text that when I drop it in, if there aren't any parens, that the precedence is going to be correct. Like, for example, they could put other operators that mess up this ternary operator. So you don't know what they're going to say. It's not like they're always just going to say a B for X, okay? It could be anything, right? And then you get this expanded source. Now we compile this. This is a very benign example. Nothing bad happened. And we'll give you an example where bad stuff happens. So what's happening here is, this is just kind of explains the pre-processing. Every use of the macro you replace with a copy of the macro body, right? But here's an example of the odd effect. Okay. Here's that same min that we did, and then somebody just goes B++, C++, right? That's okay. It just basically says take B, increment it, take C, increment it. Now, ordinarily, what I want to say here really is that I want to take B and I want to increment it. I want to take C and I want to increment it, and then I want to find out which one's the smallest. Now, it's kind of dumb on the one hand, right? Because if I increment them both, whoever's smallest is going to stay smallest because they're both going up by 1. Okay, I get it. But, bear with the example. Now, you would think that's what's going on, because if you think of this as a function call, then you evaluate B, pass it in. Evaluate C, pass it in. That is not what's happening here. What's happening here is wherever the first thing is, so in this case, B plus plus. It could say Fred. It could say anything. But it says B plus plus. I swap that out for X. I get to this Y. I swap out C plus plus for Y. I get to the next X. I swap out B plus plus. Next Y. That's what's going on here. Next Y. I swap out C plus plus. Now I've got this ternary operator where it says, I want to say increment B, increment C, and then see which one's smaller. If B is less than C, then it's B, otherwise C. I literally go increment B, check and see if it's less than increment C. No, what's really going to happen is I'm going to look at B, evaluate it, then I'm going to increment it. Then I'm going to see if the incremented B is less than C. After having looked at it, I think, no, maybe the parens are going to say increment B, and then I've got to increment C before I do this compare. I think that must be it. And if incremented B is less than incremented C, then I return literally another incremented B, otherwise another incremented C. It's a mess. It's a mess because it's a macro, not a function call. That's the tricky part. It is a macro. It's textual replacement. Isn't that weird? But again, for certain things, it's very handy, but you've got to know what you're doing here, or you set this up funky and then you call it funky because you lose track of the fact, right? Also, by the way, I never was a big fan of, when doing C, I was never a big fan of being uber tricky by embedding a bunch of stuff, because once you start embedding a bunch of stuff, now I actually have to care at that level. I got to worry about all this stuff. If I just go, B++, C++, min B, C. Boom, no problem. But it's the part where I'm trying to get fancy that causes the problem. Still, I'm free to do that in C. Okay, now there's this next idea, and it really is the same idea of, it's called capture, this phenomenon where I've got, essentially, I'll just leave it at this to try to, put this into your head. The capture basically says, you just have to remember, because it is textual replacement, then all kinds of garbage happens, okay? That's the bottom line. So I have this pound define. I call it int swap. And int swap, I pass you 2 values and it swaps them. I give you X and Y, and it puts Y in X, it puts X in Y. That's what int swap does. And here's how I define it. I got to have a temp variable, right? When you're doing the swap, you got to have a temp. I put X into temp. I put Y into X, and then I put temp back into Y, right? Yeah, well, no problem. The problem is, later on, I'm writing this program, and I just happen to, by coincidence, have a local variable called temp that I assign to be 1, and then a B that I assign to be 2, and then I do an int swap between temp and B. And again, if you don't think of this as macro replacement, if you think of this as making a function call, if it's a function call, no big deal. Remember scoping? This is an example of scoping where when you're doing macro replacement, there's no scope. You inherit the scope of wherever the text got expanded. It gets expanded. You were Fred out here. We talked about scoping, right? I'm Fred out here. I make a call. It's Fred in there. It's okay. We're different Freds. Not here. Not here. I have a thing that takes X and macro expands it into Fred down in the context where there's another Fred. And you know what the compiler thinks? It's the same Fred. Okay? It cannot separate that. So when I take that macro, pound defined, and then I take this function where I call that macro or use, I don't even want to say call the macro, use the macro, okay? Then here's what the expanded, so everything's the same, temp1, b equals 2, right? Then this line here, the int swap, gets expanded, and look what happens. I go bracket, bracket, int, temp equals, space temp. Okay, you see it? I got temp equals temp, and then semicolon, x equals y, temp equals b equals temp. So I assign b to temp, and I assign temp to b. It's a mess, because this didn't make any sense, right? You get the idea. So anyway, that is called capture. Again, the notion of, the variable not statically bound is free, and, if a fragment's moved, its free variables can become bound. What all it's really trying to say is, it's all fun and games until there are two Freds at the party. All fun and game until temp on the outside, temp on the initial, temp inside the macro definition, that there's also a temp, right nearby it when it finally gets used and it gets expanded textually. That's all it's trying to say.